All right, this is Math 2, Unit 9, Worksheet 4. I did the examples for you earlier on a video to help you get going on this. I'm going to go ahead and work through all the solutions on the rest of these problems. All right, so a lot of these we call guess and check or reverse foiling. Anytime I have a trinomial, the first thing I do is see if I have a GCF. I don't. So then if I'm going to be able to factor a trinomial, it's going to be into two smaller binomials. Of course, foiling method, this is why I call it reverse foiling, the two fronts have to multiply together to give you this term. So I know it has to be y times y. Then I go to the L. The last two terms have to multiply together to give you 6. Well, there are only so many options to multiply and get 6. 1 times 6 and 2 times 3. Well, because of this sign right here, I know I have to take these guys and add them up to equal 5. Well, the only things that add up to 5 is 2 times 3, or 2 plus 3. So plus 2 plus 3. Now, y times y is y squared, and we know that 2 times 3 is 6. All right, but we have to check. That's the check part of guess and check. So we go 2 times y is 2y, and y times 3 is 3y, and together that is 5y. See, the 2 out front, that's the f, that gives us y squared. The 2 in the back is the L that gives us 6. But this is the O and this is the I that gives us the middle term. So F-O-I-L is how we FOIL. All right, moving on to number 6 over here. Well, all of a sudden we got more challenging because we have this leading coefficient. So maybe I can factor out a GCF, 7, 13, and negative 24. Nope. So if I'm going to be able to factor this trinomial, it's going to be in two smaller binomials. So again, thinking reverse foiling, F-O-I-L, the two fronts are going to multiply together to give me 7n squared. So it's going to have to be 7n and n because 7 is a prime number. 7n times n is 7n squared. Okay, now the L part is going to give me negative 24. Well, what numbers multiply together to give me 24? I list them all. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. A lot of options here. All right, now this is a really tricky one because we can't just count on what's going to subtract to give me 13. In fact, none of them do. It's because I'm going to end up multiplying this guy over here times 7. Remember, those two multiply together to give me I, and these two multiply together to give me 7. Or excuse me, to give me the O. This is the O, and this is the I. So it's a little trickier here. I do have to remember I'm going to subtract, and I'm trying to come up with 13. So we could literally just start plugging these in one at a time and checking my O and my I. But that's going to be a lot of work, so let's try and use an educated guess. 24 and 13 aren't too far apart, and we've got this big 7 over here. So what if I went 3, okay? And I put the 3 here, so 7 times 3 would be 21. And look at that, that 8 would go there. 21 minus 8 is 13. So that was a pretty educated guess there, but I knew I needed to keep those numbers kind of close. So I put the 3 there, and I put the 8 here. So 8 times n is 8n, and 7 times 3 is 21n. Now we want to subtract. We know this because of here, but we want our 13 to be positive. So the bigger of these two should be positive and the smaller negative, which means negative 8. Negative 8 times n is negative 8n, and 7 times 3 is 21, and 21 minus 8 is positive 13. It's probably the trickiest one we've done so far, and it just takes a little practice. Let's move on to number 7. Okay, no GCF, so if I'm going to be able to factor this trinomial, it's going to be into two binomials. I know f is x times x to get x squared. 63, I got a lot of choices here. 1 times 63. How about 3 times 21? 4 doesn't work, 5 doesn't work, 6 doesn't work, 7 times 9 is 63. All right, well, I'm trying to come up with 16. I'm going to add these two numbers to equal 16. So it looks like plus 7 plus 9. Remember, 7 times 9 is 63. We already knew that. But we have to check. 7 times x is 7x. X times 9 is 9x. And together that is 16x. All right. So, moving on to number 8. Uh-oh, we got a leading coefficient. But we can't factor anything out. So if I'm going to be able to factor this trinomial, it's going to be into two smaller trinomials. So out front, remember the f, 3p and p will equal 3p squared. In the back, these two numbers have to multiply together to give me 21. So 1 times 21 and 3 times 7. Okay, now when I plug these in, the o and the I have to add up to 16p. So if I plug in 1 here and 3 there, that's 1 and 63, no good. What about 21 here and 1 here? That's 21 and 3. We're going to add, so that's 24. No good. How about 3 and 7? Well, 3 would be 3p, and 3 times 7 is 27. Excuse me, 21. So that's too big. Well, what I'm hoping is what's going to work is if I put 7 here and 3 here. 3p times p is 3p squared. 7 times 3 is 21. 7 times p is 7p. And 3p times 3 is 9p, and together that equals 16p. So you can see the 3 and the 7 multiply together to give me 21, but the combination of 3 and 7 with this 3p and p equals 16p. Guess and check. All right, so again, we're going to factor each expression, so if there's no GCF, z times z is z squared. To get 18 back here, 1 times 18, 2 times 9, 3 times 6. All right, we need to subtract. We need to subtract to get negative 3. Well, look at this. Okay, so I'm going to put positive 3 and minus 6, because 3 times z is 3z, and z times negative 6 is negative 6z. When you add those, you get negative 3z. So z times z is z squared. 3 times negative 6 is negative 18. And the middle tier terms add together to give us negative 3. All right, moving on. No GCF, so it's 2s and s. 1 times 6 and 2 times 3. Okay, so we need 13. So I'm thinking I got small numbers here, so I'm going to have to get up pretty big. So if I go 2 times 6 and 1, 2s times s is 2s squared. That's the front. 1 times 6 is 6. That's the back. It's the o and the I that add up to the middle terms. 2s times 6 is 12s, and 1s plus 12s is 13s. Okay, now the thing I haven't mentioned in a while, remember, your answer's right here. That's your answer. This is just checking your answer. All right, moving on to number 11. Okay. P times p is p squared. 1 times 35 and 5 times 7. And let's see, we're going to add them up and look at 7 plus 5 is 12. So minus 5 minus 7. Negative 5 times negative 7 is positive 35. Negative 5 times p is negative 5p. And p times negative 7 is negative 7p. And that adds up to negative 12p. All right. So I didn't leave us much room here, did I? 2n and n. And we have 35, which is 5 times 7, right? Well, 5 times 2 is 10. And 1 times 7 is 7. So let's go plus 5 minus 7. 2n times 5 is 10n, and 10n minus 7n is 3n. Negative 7 times 5 is negative 35. Okay, let's see what we got going here. Y and y, that's y squared. And 56 is 1 times 56, 2 times 28, 3, no, 4 doesn't work. Yeah, 4 works. 4 times, 14? 5 doesn't work. 6 times 7. Nope, 6 doesn't work, but how about 7 times 8? Okay. Now, which of these subtract to give you 1? Okay, well, it's going to be -7, +8. Y times y is y squared. -7 times 8 is -56. And -7y and +8y equals y. Okay. 5n and n. 1 and 6, 2 and 3. Well, look at 3 times 5 is 15. So 3 and plus 2, because 2 times n is 2n, and 5n times -3 is -15n. And what are we looking for? 13n, -13n. All right. Now we're doing some some difference of two squares. Remember, we want to be able to write difference of two squares as the difference or subtraction of two things squared. Once you have that, it's a pattern. Think of the pattern like this. A squared minus b squared. It's simply a plus b times a minus b. Well, this is my a and this is my b, so it's simply x plus 10 times x minus 10. Okay, over here. Well, we can rewrite this as 2a squared minus 5 squared. So it's simply 2a plus 5 times 2a minus 5. 2a plus 5 times 2a minus 5. Okay, moving on. Well, can we rewrite this as the difference of 2 squared? Sure, 3m squared equals 9m squared minus 7 squared. So this is my a and this is my b. So 3m plus 7 times 3m minus 7. Okay, 36y squared minus 1. Well, that can be 6y squared. 6y squared is 36y squared, and this one's tricky. 1 squared is 1. So a plus b times a minus b, or 6y plus 1 times 6y minus 1. Moving on. 100w squared minus 81. Well, this can be 10w squared minus 9 squared. A plus b times a minus b, or 10w plus 9 times 10w minus 9. All right, this one's pretty tricky, but I can rewrite this as 3x squared minus 5y squared. A plus b times a minus b, or 3x plus 5y times 3x minus 5y. All right, now we have 4 to do that are completely random. This one definitely looks like a GCF. I'm going to take out a 2, leaving n squared plus 6n plus 5. You always got to check, can I factor this further? Sure I can. N plus 5 times n plus 1. N times n is n squared. 5 times 1 is 5. 5n plus 1n is 6n. Okay, I'm going to factor out a 3, leaving n squared minus 9, which could be rewritten as 3 times n squared minus 3 squared. So our final answer is 3 times n plus 3 times n minus 3. Difference of two squares. All right, let's keep going here. We're almost done. I'm going to factor out a 5x, leaving x squared plus x minus 6. Okay, can I factor this guy further? Oops, let's get my 5x in there. And then x times x is x squared. 1 times 6, 2 times 3. 3 minus 2 is 1, so it's minus 2 plus 3. Okay, x times x is x squared. Negative 2 times 3 is negative 6. Negative 2x plus 3x equals x. So there's your answer right there. Okay, and finally, I'm going to factor out a 17, leaving y squared minus 1. Well, that's a difference of 2 squares. And there you have it.